All right, so number 53, 5.1, tan sine squared equals tan. All right, so anybody have any idea? We are solving between 0 and 2 pi. I said you could do these between 0 and 360 so that you're doing them in degrees instead of radians. That takes a little bit off your plate. But certainly if you want to do it in radians, you can. It says no calculator is going to be necessary. So that means, what that tells me is, the angles I come up with, remember, I'm looking for the angles that make this equation true. The angles I come up with are going to be special, okay? So, any thoughts on how to begin? If you are thinking divide by tangent, don't think that. Put that out of your mind. You cannot divide, and this is true whether it's trigonometry or anything in math, anything. You cannot divide by a variable if your purpose is to cancel it out. And when you divided by tangent, wouldn't you be doing it in order to cancel it out? So don't do it. You can't do it. All right, so that's off the table. So what I don't have many options. What's another option I have? What? No, that would be the same thing as dividing, multiplying by the reciprocal. Taylor? What? I could, but what I'm afraid is going to happen is it's going to get even uglier than it is right now. There actually is something we could try, Katie. Yeah, let's get our equation set equal to 0. Isn't that sort of a common theme? I mean, don't we often get our equations equal to 0? And that's not an unusual thing for us to do. Now, what would we do next? Once we have our equation set equal to 0, what would we do next? Factor out the tangent, absolutely. So we're going to factor out the tangent, leaving us with what? Not 1 minus, it's going to be sine squared minus 1. Now, whether you're in Algebra 1 or trigonometry class, when you're solving an equation, what is the next step after you factor? Always, after you factor, what do? Set each piece equal to 0. So tan x equals 0 and sine squared equals 1. Would you agree with me? Now, 0 is one of those very special numbers. If you try to draw a triangle, opposite over adjacent, that does not make sense. Would you agree with me? When a 0 is involved, we don't do that. What do we do instead when we have a 0 involved? We draw a circle, and we let the radius be 1, and we go around the circle, and we find places where if you did the tangent, which is y over x, you would get 0. So as you go around, where does it happen that if you put the y coordinate over the x coordinate, you get 0? Where does that happen? I'm not telling you. You have, every point here has an x and a y. Put the y over the x. Do any of them give you 0? Patty?
Well, 0.
0 gives you 0. You get 0 right here. That's exactly right, Patty. Are there any others?
180.
180. Exactly. Both of those places, if you put y over x, you get 0. What about up here?
That'd be undefined.
That'd be undefined. You can't, that one doesn't work. That one doesn't
Divided by
work.
0 ends the universe, so yeah.
Okay.
Don't do that.
So 0 and 180 are answers. Oh, Patty. Our answers are 0 and 180 for this part of the problem. Everybody good? All right, so I got 0 and 180. All right, now I have to solve that one. How am I going to solve that? Take the square root of both sides, and just like has always been the case in your entire mathematical life, When you take the square root of both sides, it's plus or minus.
And then we split.
So now we're going to look at our circle again. And we're going to go around the circle. And we're going to find places where you put y over r and get plus or minus 1, either positive 1 or negative 1. So where does that happen? As you go around the circle, remember r is 1, you built a circle with a radius of 1. So where does it happen? If you put the y coordinate over 1, you get either positive 1 or negative 1. Where does that happen? It happens right here. And it happens right here, doesn't it? Up there you get positive 1, down here you get negative 1. So these two answers are 90 and 270. This is a tough problem though. This is a tricky problem. These two roots are extraneous. That's tough. That's hard. It's hard. You're saying to yourself, Mrs. Ford, why are they extraneous? Take your calculator out, and let's say you want to check this answer. All right, so to check that answer, you type tangent 90 times sine 90 squared, right? All right, so go ahead and do that. Type tangent 90 times parentheses sine 90 squared. You're checking your answer. We're checking to see if this is a good answer. Tell me what happens when you do, make sure you're in degrees. Tell me what happens when you do that. You get an error. Anybody want to explain to me why I got an error? I should look right up here at this angle. This is 90. Tell me about the tangent up here. It's undefined. Any problem that involves a tangent cannot have a 90 or a 270 as an answer. Because if you think about when you graph a tangent, what do you have at 90? Pi over 2 and negative pi over 2. What do you have? Asymptotes. That means it's undefined. So whenever you do a tangent problem, you cannot have an answer that's 90 or 270. Okay? All right, Chloe?
Why couldn't we get 360 when we're trying to find 10?
What do you mean?
Like,
Oh, the directions say zero's included, 360 is not. It's just tradition. Traditionally, we just don't include. Yep. We use the smallest one.
okay.
It would be like using 450 instead of 90. Why would you do that? You wouldn't.
So it's always going to be that way?
This is common sense. Okay. All right, so we did this problem in another class, and the kids said, oh my gosh, do I have to worry about extraneous roots all the time? No, you don't. Think about a sine curve. Are there any asymptotes in a sine curve? Are you going to have to worry about extraneous roots if it's a sine problem? Nope. If it's a cosine problem? Nope. If it's a tangent problem, you do. Where are the extraneous roots going to be? 90 and 270, period. That's it. You don't have to worry about anything else but 90 and 270. If it's a cotangent problem, then the extraneous roots would be at 0 and 180. That's where the asymptotes are there. So if your problem has tans or cotans, then you better be thinking about, okay, I could get extraneous roots. But if it's just sines and cosines, you don't have to stress about it. Doesn't happen in sines and cosines. That's why they're our favorites. Okay? All right, anybody else try a homework problem and have an issue?
Can you do 63?
63 on the same page? Use a calculator, cosine x equals 0.37. All right, so obviously if I'm using a calculator, this is not a special angle, and you can see that. This says find the angle whose cosine is 0.37. Where will that angle be? Well, which quadrants will that angle be in? We're going all the way around the circle, so where could I have a cosine that's a positive number? 1 and 4. I can have a cosine that's positive in 1 and 4. Alright, I have no idea what the angle is whose cosine is 0.37. Since I'm finding an angle, what button will I press? Second cosine, 0.37. And that comes out to be about 68.3. So what are the two answers to the problem then? One of them is 68.3. What's the other one? 291.7. Now, when we solve equations, the directions are going to look like this. They're going to be one revolution. This problem is a little bit different because it says find all the solutions. Okay? Now, there's more than these two. Can anybody explain that to me? Why are there really more than those two? That's right, Ross is going like this. If 68.3 is an answer, wouldn't this also be an answer? And wouldn't this also be an answer? If I were to find all of the answers, not just the ones in this interval, but all the answers, there would be infinitely many. It would be 68.3 and all of his coterminals, and 291 and all of his coterminals. So if we were, I'm not going to ask you to do this. I'm going to give you directions like this. So this would be the answer. But if we were going to follow the directions in the book and list all of the angles, we'd have to say plus or minus 360n, where n is a whole number. Now what is that doing? I know it's letters and symbols. Do not be confused. How do we find coterminal angles? We add or subtract 360s, right? And it's either I could have one 360 or two 360s or three 360s, so that's how I express it. If I want all of the answers in the whole wide world that would have a cosine of 0.37. Okay, tell me.
26.
Okay, this is the last one I'm going to do, because we have to do some other stuff. So 26 on this page. Now this is not an equation. This is a simplify. So this is kind of like what we do when we're doing our verifications. We're trying to get it boiled down to something simpler. So let's see. We got secant squared minus tangent squared over cosine squared plus sine squared. Now, my brain is just popping. I got bells ringing all over the place. Whenever I see functions squared, I immediately think about my Pythagorean identities. Now, they don't always work, but they're right there at the forefront of my mind. That denominator, guys, we gotta recognize that. That denominator is 1. That's 1. Now, the numerator, that is not something that I memorized, but I have one that's got those things in it. What did I memorize? 1 plus tangent squared is secant squared. Well, now wait a minute. If I did a little rearranging here, if I moved this guy over to this side, what would that say? Secant squared minus tangent squared, which equals 1. So that thing simplifies to 1. Now again, if you don't know your identities, you are dead in the water. You have got to get these things memorized so that you can see stuff like that when it comes up in a problem. All right, speaking of seeing things, we need to do a few more verifications. We need to practice this a little bit. So get your packets out, and the very front page, there are 30 of them that we have to practice. So let's pick a couple, get warmed up here. So anybody see anything interesting? 1 to 30. They all look fascinating. Just pick one. Okay. Thank you, Hannah. Number 21. Oh, this kind of a challenging one, actually, Hannah. Good pick. Alright, so this is a good one. This is a good one. And there's, like always, lots of ways to do it, but I want to give you some things to think about. I want you to think about this for a minute. We're going to try to turn this into that. And in order to do that, we got to get rid of the cosines, right? Because we are ending up with only tangents. Make sure I got all my letters in the right order, did I? Yeah. We are ending up with only tangents, which means I have to get rid of cosines. Now this is a little bit sophisticated, but I think you can follow it. Cosines in the denominator, think about this. This is the same as this. Would you agree with me? Cosines in the denominator are really just what? What's 1 over cosine? No, 1 over cosine isn't sine. What's 1 over cosine? Secant. Guys, reciprocal of cosine. Secant. So I'm going to think of that as a secant squared. Now, can anybody tell me why I would want to do that? Why am I very comfortable with a secant squared in this problem? I did not like the cosine, but I made it a secant, and now I'm very comfortable. Why? What about secant squared? What about secant squared? What is secant squared equal to? 1 plus tangent squared. And why is that good news? Because I only want tangents. So if I can get rid of my secant by replacing it with tangent, then life is good. Alright, so let's back up and make sure you follow that. This is a tough problem. Okay, this is a tough problem. On like a scale of 1 to 10, this would be definitely like a 4 or 5. Most of your problems here are like 1s and 2s. So this is a tougher one. So we're going to get rid of these cosines. Since they're in the denominator, I can turn them into secants. And then we're going to get rid of the secants by changing them into tangents. Very logical, because I want to end up with just tangents. And what do I have here in this line? It's not cleaned up, but what function do I have? All tangents. So hopefully something will cancel out. So if I distribute, and don't forget to distribute the negative too, what happens? When I distribute my tangents on those parentheses, what happens? You notice anything? this one and this one cancel, don't they?
Yeah.
And what are we left with?
Tan squared A minus tan squared B.
Which is exactly what we wanted. So we're done. We did it. Remember, your goal was to take this and change it into that, and you did. That's all you have left is tangent squared A minus tangent squared B. All right, good choice, Hannah. Somebody pick another one. See if we can get another good one going here.
24.
24. Actually, 24 has some similarities to this one, in that you want to get rid of all this. All these signs have to go, and you have to change it into cosines. Just like over here, the cosines and secants had to go, and we had to change it all into tangents. Anybody notice anything about this? No, we can't factor out a sign because we got 1 here. Antonia?
Sine squared equals 1 minus cosine squared.
Absolutely, that's true. But yes, you are right. And I could approach the problem from that standpoint. I'd have to, this is going to be a little complicated over here, but I absolutely could do that. And we will. I'll do it both ways to show you how that works. But we can make the problem much simpler if you notice something about this thing right here.
Is it the degree?
It is the same as 1 minus 2x plus x squared. You can factor it. Now this would factor as 1 minus x. 1 minus x. What is my x in this problem? Not sine. Sine squared. This is 1 minus sine squared times 1 minus sine squared. Now, if you notice that, you're home free, because what's 1 minus sine squared? What's 1 minus sine squared?
The cosine.
That's cosine squared. So this is cosine squared times cosine squared, which of course is cosine to the 4th. So if you notice that factors, this is a 2-step problem. Now, Antonia's thought was beautiful. It's a little bit longer, but boy, it'll work. She said, I know that sine squared is 1 minus cosine squared. So she says, I'm going to take that sine squared and I'm going to change it into 1 minus cosine squared. Now, what about sine to the 4th? Sine to the 4th is sine squared squared. Would you agree with that? So I'm going to make this 1 minus cosine squared squared. Now there's no identities for fourths, so don't think you can do that. But you can think of it as the squared squared and then use your identities. So now if I do my distributing and my foiling, I have 1 minus 2 plus 2 cosine squared plus, this is a FOIL, 1 minus 2 cosine squared plus cosine to the 4th. What happens? The 1's cancel. The 2 where'd that come from? Oh no, the 1's don't cancel on the same side. 1 minus 2 is negative 1. That cancels. There we go. And 2 cosine squared. All that's left is cosine to the 4th. So you could do that, Antonia. very surely you could. And that's good logic too. You said I got all these sine squares, I'll just change them into cosine squares. All right, let's do another one. Pretty soon you gotta be able to do this by yourself. You have a quiz someday.
28.
Which one?
28.
28. Looks simpler. Let's see if it is. What are your thoughts when you see number 28? Could you even do anything to get started? Into? All right, so we could write this as tangent over sine squared. You in agreement with that?
What function are we trying to change them all into?
What?
What function are we changing them all?
Well, we want to end up with that. That's what we got to end up with. And we get no points for doing nothing. We get points for everything we do that's right, even if we don't get to the right place. If what we're doing is right, we get points. So sitting there staring and doing nothing gets us nothing. We gotta think of something. What? We might make a wrong turn and have to start over, and that's fine, but we gotta do something. So if you look at this right here, what can you do? What about tangent? What's tangent? Sine over cosine. So let's just change sine over cosine, see what happens. So now I've got sine over sine squared. That's a mess. You can simplify that any way you want. I will always simply multiply by the common denominator, which is cosine. So that's going to leave me with, you can invert and multiply if that's what you want to do. Whatever you want to do, you got to get it simplified, and you end up with sine over cosine sine squared. Because I multiplied to cancel those out. So that's what I end up with. Well, what do I notice about that? Sines cancel. So I'm left with 1 over cosine sine. Now, is that the same as 1 over cosine times 1 over sine? Are these the same thing? What's 1 over cosine? Secant. And what's 1 over sine? Oh my. Isn't that what I wanted? There we did it. Took a few steps, but it wasn't too bad. It wasn't too bad. Okay, one more, then we'll look at a practice quiz. Did I see another one there that looks interesting? Both sides of the page, there's just full of them. Sixteen. Now, when it equals 0 like that, that means everything has to cancel out. So it might be good, let's just think about this for a second. If I have to make everything cancel out, do you think it might be a good idea to get everything over here like terms? Because you're going to have to be adding and subtracting things to make them all get to 0. Everything's got to get wiped out. So everything over here is a cosecant, except that. We stand a better chance of canceling if it's all cosecants, right? Does that make sense to you? So what about cotangent squared?
1 plus cotangent squared.
Okay, so I have an identity, and I usually have to write them down. I have an identity that says 1 plus cotangent squared is cosecant squared. So what does cotangent squared equal? Cotangent squared would equal cosecant squared minus 1. And again, it's very logical. This isn't just some random thing we're making up. We know all this has to cancel out to be 0. So if you want to start adding and subtracting things and making them cancel out, they have to be like terms. So we'll just make everything a cosecant. All right? Now what about that? Now that I have that written there, tell me about that. What's cosecant squared minus 1? It's called the difference of squares. And what can I do with the difference of squares? Factor them. And how does that difference of squares factor? Cosecant minus 1, cosecant plus 1. Oops. And what's just wonderful about that? Those are gone. So now what I have left is cosecant minus 1 plus 1 minus cosecant. What happens there? It's all gone, just like we'd hoped. And we end up with 0. All right, you turn, let's see, turn a couple pages on what would be the 3rd page of your packet. There's a practice quiz. There's actually 2 of them. We're just doing the one at the top right now. There's a practice quiz, okay? So what I'd like you to do is take a few minutes and see if you can do that problem. See how far you can get with that problem. If you want to work with your partner there, that's fine. See what you can do with this. Because like I said, it won't be long and we'll be having a little quiz like this. Yes? I didn't hear you. Does anybody have an idea to get us started?
Sine squared.
Okay, now, this is a key thing to keep in mind. We have an identity that allows us to change sines into cosines. For example, sine squared is the same as 1 minus cosine squared, right? Those identities that allow you to change sine into cosine, or tan into secant, or cotan into cosecant, those identities only work if the functions are squared. So you might see a 1 minus cosine and think, oh, 1 minus cosine, that's sine. No. 1 minus cosine squared is sine squared. But there is no change in that guy. He is not going to change. The only way you can change them is if they're Pythagorean. They have to be squared. Okay, got that? Okay, so we're not going to do that, all right? So did anybody have a different idea? That's a very common mistake. People do that all the time, even grown-ups. We don't want to do that. We don't want to do it. Can't do it. So what's another idea you have? Guys, what are these? Fractions. You're adding fractions. How do we add fractions? We get a common denominator. Now, listen, again, that's perfectly logical. How many terms do you have on this side? 2. How many do you have on this side? 1. Somehow, you have to get the 2 into 1. And since they're fractions, that's easy. Get a common denominator and add them. Okay? So here we go. My common denominator will be 1 minus cosine, 1 plus cosine. That's going to be my common denominator. This guy will have to be multiplied by 1 plus cosine, right? And this one will have to be multiplied by 1 minus cosine in order for them to have the same denominator. So I've got 1 plus cosine plus 1 minus cosine. Okay. Now, it's a big thing, but there's only one thing now, one big fraction. What I just did, gang, is the same thing you would do if you were adding 1/3 and 1/4. You multiply this one by 4 and this one by 3 so that your common denominator is 12. That is exactly what I just did, but I did it with the functions instead of with numbers. All right, so where do you go from here now? I think some of us are hesitant because we're afraid we're going to say the wrong thing. There's no wrong answer. You got to do something. Well, I shouldn't say that. Yes, there will be some wrong answers, but you have to do something. You've got to do something. So you look at that numerator. Look, what? These cancel, and I'm left with 2. Okay, great. Now, what about the bottom? You FOIL it, absolutely. So we're left with 1 minus cosine squared. Oh my gosh. Ding, 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 ding. 1 minus cosine squared. 1 minus cosine squared. Sine squared. That's your Pythagorean identity. 1 minus cosine squared is sine squared. So now we have 2 over sine squared, which is the same as 2 times 1 over sine squared. And what's 1 over sine squared? 2 cosecant squared. Which is what you wanted. Okay? All right, let's try practice quiz 2.
Oh, no.
Now, I'm gonna give you a little hint, and this is, when we verify identities, there's no hard and fast rules about which side to start on and all that stuff. It's wide open. You can start on whichever side you want. But years and years of experience have made me believe that if your choices, and which side am I gonna start on, if your choices are an addition or subtraction on one side and a multiplication or division on the other side, start with the add and subtract side. I think it's easier, personally, and that's just based on my experience, if you pick the add and subtract side. So if I am doing practice quiz 2, I'm gonna start by messing around with tangent and cotangent. All right, so take a minute with your partner or by yourself and see what you can do with that one. Think about what you know, think about the identities you have. What can you do with that one?
Like how this is like 1 over sine squared, but then cosecant is only just 1 over sine. It doesn't have a squared.
But 1 over sine squared is cosecant squared. Yeah.
Well, because 1 doesn't it? You just got it.
Did somebody say you got it?
Yeah, I think. Wait, but where does this go? I didn't think I was doing the right thing, and then I was.
Are we excited when we get it?
Oh.
All right, so let's talk about, Mrs. Ford has kind of already given you a hint that when you have this dilemma, sines and cosines are the very best things to have. All right, those are the best things to have. This problem has no sines or cosines. One has all weird functions, all a bunch of different functions. This side has a plus, this side has a times. It's easier to start on the plus side. All right, so we've decided, or I decided, I told you, let's start over here. Okay, what can I do over here? Remember, you get no points for sitting there. You have to do something. So when you look at this, what can you do? Abby? Tangent is sine over cosine, and cotangent is cosine over sine. Now, if you don't have those memorized, you can't do that, and you will get a 0. All right, now what? We're back to where we were a minute ago. We have 2 fractions added together. There's no addition over here. We got to get this addition taken care of. We got to get these things added together. So our common denominator will be cosine sine, right? This one needs to be multiplied by sine. And this one needs to be multiplied by cosine, so that they now have the same denominator. So on the top I have sine squared plus cosine squared.
That's 1.
Ding, ding, ding. That's 1 over cosine sine.
Split it up.
Now we split it up. That's the same as 1 over cosine times 1 over sine. Now, if you are uncomfortable doing something algebraic like that, go ahead and do it, and then put it back together and make sure it matches what you started with. If I multiply these two together, do I get this? Then it was perfectly okay to take them apart. Because when I put them back together, I get this. All right, now look at what you have, look at what you want. You're there. Because this is secant and this is cosecant. And that is exactly what you wanted. Okay? I got one more on the back, I think. Oh no, I got 2 more on the back.
No.
All right, so let's take a look at number 3. Take a couple minutes, see if you can, how far you can get with number 3.
Oh.
All right, see how far you can get with number 3.
Now you can cancel out All right, who's got a plan? Anybody have a plan? This is all wrong. Erase all of that.
Absolutely. All right, so let's start with what is painfully obvious. You're ending up with something that has only cosines. Over here, you got a sine squared. Now that is a real easy fix because we know sine squared is 1 minus cosine squared. So that would be what I would consider an absolute no-brainer. We need to be able to see that. All right? Now, that denominator we have handled before. 1 minus something squared is the difference of squares. Notice there are no squares in the answer, right? Which tells me what has to happen. I gotta get rid of something. I gotta cancel something out. I've got way too much on this side. And one way to cancel is to factor, right? So that denominator factors into 1 minus cosine, 1 plus cosine. Now I need you to take a big view of that numerator. That numerator factors. You gotta start picking up on that. That numerator is exactly the same as this. That's what you got. How would you factor that? How would this factor? Minus what? Minus 4x plus 1x. Okay, some of your factoring skills are really awful, and I'm sorry about that. I mean, you need to be able to factor. So
1 minus 4 cosine.
Exactly. 1 minus 4 cosine x and 1 plus cosine x. And what happens?
Cancel. No,
These cancel, and what are we left with?
the answer.
Exactly what we wanted. So, things that are going through our mind. I need all cosines. I need to get rid of stuff. And you get rid of stuff by canceling it. And in fractions, that means you have to factor first so that you can cancel them out. All right. Well, let's give one more a shot. The last one there, down at the bottom. Give it a shot. See how you do. Think about all the things we've talked about, all the different strategies we've used. This is a little tougher. What are some ideas so far? What are you trying? Common denominator? That makes sense. So let's see. Excuse me. Our common denominator would be 1 minus cotan, 1 minus tan. So we'd have tan, 1 minus tan, plus cotan, 1 minus cotan. Alright, does that make sense to everybody? This time I didn't write it down with my red marker. Is that okay? Did everybody follow that okay? This one needed a 1 minus tan, and this one needed a 1 minus cotan. Alright. That's a way to start for sure. What else? Or what next then? If that's how we start. And that makes perfectly good sense to me. Alright, what else? So what would we do now? Well, nothing cancels at this point. If we started canceling appropriately, we'd end up right back where we started. So I don't think I'm ready to cancel yet. What do I need to do? Maybe just kind of clean things up a little bit. So I'll have tan minus tan squared plus cotan minus cotan squared over, FOIL that out to 1 minus tan minus cotan plus tan cotan. This is a frightful mess. Did you notice this is just, what's tan cotan? Tangent times cotangent. They're reciprocals. So that would just be 1. Okay, you guys got me into this mess. What now? I could add the 1s and make it 2, but what am I doing here? You can't cancel anything. If you can't factor, you can't cancel.
But it does a
What? Well, keep an eye on what I'm trying to end up with up there. I think,
oh, the tan squared plus 1 equals 2.
well, I don't have a tangent squared plus 1. I do have a tangent squared, but I got way too much crap here. I need to get rid of something. So I think I'm going to change it all into sines and cosines, and hopefully something will cancel. Now, I probably personally would have done that in the beginning, but we didn't. And it makes sense. Doing all this makes sense, but now we got this mess we have to deal with. So sine over cosine minus sine squared over cosine squared plus cosine over sine minus cosine squared over sine squared all over 1 minus sine over cosine minus cosine over sine. Actually, I'm going to make that a 2 since that was just a 1 there. What's the common denominator of the whole shebang?
Cosine squared, sine squared.
Alright, so I'm going to multiply everything by sine squared, cosine squared, and get rid of all these fractions. And you're probably going to run out of room on your paper, because this is going to be a long one.
I'm running out of room in my head to do this problem.
We'll go back and I'll show you maybe a more efficient way of doing the problem. But here's what's going to happen. You're on your own taking your quiz. You're going to get rolling and you got to finish it. So we're going to finish it. We're going to see what happens. Now, what is the purpose of multiplying everything by the common denominator? Well, some things are going to cancel. So I have sine cubed cosine minus sine to the fourth plus cosine cubed sine minus cosine to the fourth. This is a lovely mess. Yep, this is gonna take some pondering how we're gonna get out
Oh
of
my
this.
Bruh. Bruh.
This may be one of those times, I mean, there's some
Start over.
factoring that we can do, and some rewriting that we can do. But this may be one of those times when we just say, you know what, maybe we should start over.
Hit that reset button.
Hit the reset
Oh my
button.
god.
All right, so let's
We've gotten
do,
so far into it.
let's go back to the beginning and see if we can get this guy done before, before we run out of time. So here we go. All right, so what was our original plan was we got a common denominator. That is a good plan, but like proofs in geometry, sometimes you get going and all of a sudden you get to a point and say, wait a minute, let me try something different. So that's what we're doing, we're trying something different. So let's take this, just this one, and let's change just it into sines and cosines and see what happens. So we'd have sine over cosine over 1 minus cosine squared, oh no, it's not squared, just 1 minus cosine over sine. All right, is that okay with everybody? Now, I know I still have that one, but I'm just gonna work on this one for a minute. So I'm gonna multiply everything here by cosine sine, because that's the common denominator of this little fraction. I'm multiplying everything by cosine sine. So my numerator turns out to be sine squared, and my denominator turns out to be cosine sine minus cosine squared. You okay with that? That's just this fraction. I haven't done that one yet, but just this one. Multiplied everything by cosine sine and cancel out the stuff that cancel out. Now let's repeat the process for this one. So this will be cosine over sine over 1 minus sine over cosine. Okay, and let's multiply the same way we did before by sine cosine. So we end up with cosine squared over sine cosine minus sine squared. Now, I need a common denominator, don't I? Because I got two big fractions added together and those denominators don't match, although they certainly have some overlap. what is, could I factor that denominator? Because they look like they have so much in common. I'm thinking if I factor out a cosine, I'll have sine minus cosine plus, take out a sine, and I have cosine minus sine. Now I need a common denominator between those two fractions. What would I have to do to make those denominators the same? Not much, actually, not much. If I multiplied this, if I made this a negative sign, a minus sign, could I turn that around? Could I, in other words, can I factor a negative out of this parentheses? So if I did that, it would look like this. So what would it take to make these denominators match now? Not very much. It would take, this one has to be times by sine, and this one by cosine. Now do the denominators match? So now I got sine cubed minus cosine cubed. Uh-oh. Think back to second year algebra. Can you factor cubes? The difference of cubes. Anybody remember how to do that? A cubed minus b cubed. Anybody remember that little like formula thing? Give you a hint. It's a little parentheses and a bigger parentheses.
Like A minus B?
Depending on who your teacher was, they may have talked about soap.
Yeah.
Okay, so this would be a minus b,
A squared
a squared, ab, b squared, and soap means same, opposite, always positive. Wow is right. Gotta remember stuff. So this becomes, I'm gonna do, my A and my B are sine and cosine. So I'm gonna have sine minus cosine. I'm running out of room. Let me do it over here. Running out of room. So I have sine minus cosine times sine squared plus, I gotta remember that's what I'm trying to end up with, plus sine cosine plus cosine squared.
Well, I'm lost.
No, don't be lost. You got it. We're almost done. Hang on, we'll finish it. These will cancel. I was trying to end up with 1 minus secant cosecant, right? That's what I'm going to end up with. 1 plus secant cosecant. All right? Yeah, we went from down here. I factored. This is my factorization of my cubes. This part cancels. So now I'm left with this, which is 1 plus sine cosine over sine cosine. This is 1. So 1 plus sine cosine over sine cosine. Now I'm going to split that apart and say that's 1 over sine cosine plus sine cosine over sine cosine. Now again, when you make an algebra move like this, if you're unsure of it, go backwards. If I added these two together, is this what I would come up with? So it's perfectly okay to split it apart. Now what's this?
That's your secant.
That's your secant and your cosecant. 1 over sine, 1 over cosine. There's your secant and your cosecant. And this is 1. That's what we want to end up with. Okay. So, that will not be your quiz problem. But, it's good exposure to, sometimes it takes more than 1 or 2 steps to get to the end. All right. Tomorrow we have class, right? So tomorrow we are going to actually start 5-3, but we will practice a couple more of these, all right? And my thought is we'll practice a couple more of these tomorrow. We'll practice a couple more our next class, and then the class after that we're having a quiz. So we have 2 more days. Won't be totally devoted to this, but we'll be practicing a couple each day. In the meantime, you're working on homework, so you have stuff to ask me, right? The same. What do I see in your hand? Yes. And I think I'm probably going to give you your first cathedral detention. I am so sorry, but that is life. No phone zone, honey. No phone zone. I'll see you guys tomorrow. Would you turn that off? Take it off? Thank you.